Let's start defining the Grasshopper component to get the geometry from our Tensegrity elements. So for that, when I'm going to create a new component, what I usually do is to copy an existing component so that I don't have to start from scratch again. Let's just use Ctrl+C and Ctrl+V to copy our component of our Tensegrity here. Okay, so now here we are, and the first thing we need to do is to rename the, let's say, the class file. So instead of being component Tensegrity, now we are going to name it extract geometry, like that. And again, it's quite important to write the word component at the beginning of this file name so that all my components are grouped together here in the Solution Explorer. So now let's go into our class. So of course, the first thing we have to do is to rename the class with the same name as we have just written here. And now let's extract geometry, and now let's go step by step. So the next thing we have to do rather is to change our identifier. We don't have to forget that, so that's what I am doing it right at the beginning. So for that, we just have to come to this website once again, gitgenerator.com, and generate our new random git and come back to Visual Studio. So now we can insert this guy here, and now the next thing would be to add an icon for this component. So this is nothing new again. So let's come to here, project, Tensegrity properties, and we are going to add an existing file, which, well, I'm going to add at the same time these two files because we are going to be using the other one later on. But let's save this properties file, and let's get back to our component, and the icon is going to be visualization icon. Perfect. Okay, so now let's start from the beginning. So this is going to be not a Tensegrity, but extract geometry, and let's call this geometry. Yes, so for instance, extract geometric data from a Tensegrity element. Okay, like that. And now let's change our input parameters. So the input parameter is going to be a Tensegrity element that we are going to provide this component with. So again, this has to be now a generic parameter, like that. And this is going to be element e and just Tensegrity element, like that. Perfect. This is my input parameter, and now the output parameter is going to be, of course, the geometry related to that Tensegrity element. So in this case, add geometry parameter, and this is going to be geometry and G, or yeah, yes, why not? And this is the geometric data from a Tensegrity element. Okay, fantastic. Now let's move on, and now this gets a bit tricky. So this is the solve instance method, and if you remember, let me erase everything here. So if you remember, this is the method that defines the action of our Grasshopper component. So the first thing we need to do is to assign this input parameter into a variable that we are defining here. In this case, let's call it like input element. And we are going to define this variable as a special object, which is a Grasshopper object wrapper. And I'm getting an error here because hopefully I have to reference this library here. Okay, perfect. And now, yes, all right. So this is my object wrapper, and this is a way that Grasshopper allows the user to create Grasshopper components so that they take objects as input and Grasshopper can recognize those objects. So now we are going to assign the data into this object wrapper. And now what we want to do is to get the geometry. So if you remember, we can, if we come, for instance, to the Tensegrity bar class here, we already defined this method to geometry so that we can take this let's say bar object and get a line as output. So this is the method that we are going to use. Let's get back to our component. So let's say bar and now output geometry. So now we have first to get our bar object, and this is a bit tricky. So the first thing we need to do is to take our object wrapper here and take the value from it. So basically this is the actual object that the object wrapper is wrapping. And now what we have to do in order to apply this method is to cast this object into the, let's say, Tensegrity bar. So let's do it like this, Tensegrity bar. I hope it makes sense. And that's right, so this should be from here till here. I mean, we already saw how casting in C# works, if you remember from chapter 1. So perhaps this should be a good point to review that content if you don't remember that. And now we can apply the method to geometry, and that should be it. So now we can see here that we are getting that's right, this kind of geometric Grasshopper data. So now we can put this here, but this is not a list anymore. That's important. This is just an item. So let me change it here as well. Thank you for reminding me, Visual Studio. So it seems like that should be it. But of course, this definition, so this script, is only going to work if we provide Tensegrity bars for our strat elements. But what happens if we want to get the geometry from our cables or even from our support? What do we have to do? I mean, do we have to create additional Grasshopper components, or can you find a way, or using this same method so that we can get the geometry from any kind of Tensegrity element? So if you want, you can pause this video for 10 seconds to see if you can find the solution. And congratulations if you know the answer, because actually, if you remember from chapter 1, we saw a concept that is polymorphism. Okay, that means that what we're going to do is to create a parent class related to all of our Tensegrity elements, so that they are going to inherit that class, in order that we here, instead of, let's say, using our element classes, we are going to use this parent class so that it can work with its element of our Tensegrity that we provide, regardless if it is a bar, a cable, or a support. So now let's define this parent class we were talking about. So let's come here and we are going to add a new class. Why not? And actually, this is not going to be, we don't call this thing class, but interface. So let me explain it in 1 second. And we name interface with the letter I at the beginning. So this is going to be interface, then Tensegrity element. Okay, like that. And this has to be public, of course. And this is not a class, but an interface. Okay, and the thing is that now we have to define the properties that our other children classes are going to inherit. So these are basically these ones: to a string, to geometry, and to goal object. Actually, I think we don't have to do anything with this one, because we are not using the parent class to show messages in balancing Grasshopper and so on. So we just need to define these methods here. Let's get back to our interface. Okay, and now of course we have to add the references to first of all the Grasshopper library, and this is not public, I'm sorry for that. And that's right, and now we have to copy, the other method, in this case the goal object, like that. Okay, and of course we have to reference the Kangaroo library. Perfect, so now, of course, this is our interface, and it's called an interface because there's nothing going on here. We just have defined some methods so that the children classes can implement these methods. That's just the point of interfaces in C# or even in object-oriented programming. And if you understand this concept, you are really far away, trust me. So now we are going to come back to our classes and we are going to make them inherit our newly created interface, which is Tensegrity element, and it should be working because these methods have the same exact name as the ones that we have just described in our interface. And now let's do the same with our Tensegrity cables and with our supports. Where are you? Oh yes, sorry. Okay, so now if we come back to our Grasshopper component once again, what we can do is here, instead of using a Tensegrity bar, to use our interface Tensegrity element. That should be working regardless of this is let's say, as we said, regardless if this is a bar, a cable, or a support. Okay, so let's check if this is working. Now let's compile our our Grasshopper assembly and let's test it in Visual Studio, in Rhino I mean. Okay, so now we are in Grasshopper, and later and in the previous, let's say, example, I saved the Grasshopper definition before closing the program. So let's try to, okay, here we are. And now if we come to K2 engineering once again, where are you? And now we can see that we have another component here that is the one that we have just created. So the idea would be, let's check if this works, that this is our Tensegrity, so these are our objects, and if we plug these guys here, yes, we can see that now we are seeing in this case the polygonal cables, and if we plug, I don't know, let's say the bracing cables, yes, we should be able to see them as well. And finally, these are my struts, and these are my supports. So yeah, this is a perfect way of getting the geometry as geometrical output from Grasshopper. And again, we can change if we want, we can change the geometry of our Tensegrity, and it should be working like that. Okay, so now now it seems like we are at the same plane as we started, because now we are able to see the geometry of our Tensegrity once again. But now you are going to see that with these objects, it's quite easy to run this simulation with Kangaroo. And now let's define the Grasshopper component for extracting the Kangaroo goal from our Tensegrity elements. So as before, let's start copying this component, extract geometry, as a starting point for our new component that we are going to call, or to rename, extract goal. Extract goal, like that. Perfect. So again, the first step is to rename the name of our class. And by the way, just take a second to see how nicely sorted our Solution Explorer looks like. And that's because we have renamed our components and classes in such a way that they are grouped together, yes, regarding if they are a component or a class or another thing. Okay, so again, let's come back to our new component here. We have just renamed the class and the constructor, and now we have to get a new Git identifier. So let's generate a new one and let's insert it right here. Perfect. So now we have to add the new icon, and if you remember, we already added it into our project in the just a few minutes ago. So that should be icon Kangaroo goal. Okay. And now, since this is the same as before, I'm going just to copy this from solve instance to my constructor so that I don't have to go step by step again. Oops. So basically this is my constructor. I've just changed the description from my previous component, and now this is my input Tensegrity element just as before, and this is my output parameters. Yes, in this case the output parameter is going to be a Kangaroo goal, so in this case it's another generic parameter, and again we have to take the input element as a Grasshopper object wrapper, and with this command we are getting the Kangaroo goal, because you can see here that we are using the toGoal object method from our, let's say, not only Tensegrity elements here, but also from this interface, so that we can use the same command line for all of our objects. And now we set this goal as output, and that should be it. So let's get back into Grasshopper and test it again. Let's click in start and let's go for it. So we are back in Grasshopper, and here we have our Grasshopper definition from before. And by the way, I think there's no point on uploading this Grasshopper definition, because since this is using my plugin, the thing is that if you try to load this Grasshopper definition with the plugin that you are compiling, you are going to get an error, because your, let's say, component identifier, your Git, is different than the one I am using. So if you load my definition, you could get an error. So that's the reason I'm not going to upload this Grasshopper definition. But anyway, let's try this new component, extract goal, that we have just implemented. So now what we can do is, of course, to plug our Tensegrity elements from our Grasshopper component here, and we are getting a Kangaroo goal as a result. But instead of, let's say, plugging all output parameters one by one, what we are going to do is basically to plug them as a tree structure, because that way it will be much easier later on to visualize the output or the outcome of this Tensegrity structure. So now we can see that we are getting also the tree with the same structure, because in Visual Studio we define the input and output as items. So I am getting exactly the same structure, the same data structure as I am providing to this component. So if we take a look into this, we can see that now we are getting actually K2 engineering objects as result. And now we can notice the difference between our objects and these objects here. So you can see, for instance, that we provided let's say a more or less detailed description of the properties of our object, and we did that with this toString method, and here they didn't implement this method. So yeah, you can see what happens when you don't do that you cannot get any kind of information regarding the properties of that object. So that's actually something positive from our plugin. And now basically let's test if this works with Kangaroo. So let's try to get the Kangaroo bounce dissolver. So these are my goals here, and now we need a reset button, sorry, like that. Perfect. And now we would like to visualize the output. So for that, what we have to do, of course, is to create this kind of vertices, or output rather, as a tree, as we did before. So for that, I'm going to unflatten my tree. This is my tree, and the reference is going to be this guy here. And what we can do that now is to come to K2 engineering, and if we come to display, we should be able to get the actual visualization component. But before that, we need the results in terms of this, not displacement, yeah, that's right, but bar output. This is the one that we are looking for. But of course, let's explode this tree structure before. Explode tree. And 1, 2, that's right for now. So first, the first branch were my polygonal cables, so these guys here, and let's take a look into them. This is my, you can see that there are some indexes here, and these are my lines, and this is the axial force. I guess it's not very big because the pre-stress force is not big as well. So now what we can do is to plug here my lines and my axial stresses, and here we can already start visualizing our stresses as, of course, as tension forces, because all cables have to be in tension. And now we can do the same with our other cable elements, also in tension. And now if we plug our struts or compression elements, this should be in compression. That's right. Okay, so it's looking nice, and we don't have to do anything with our supports because we are already visualizing them. So this is my Tensegrity structure, and you can see how Kangaroo iterates a bit until it finds the equilibrium, let's say. And we can try, for instance, now changing the geometry. So now we can add one level more, or even, I don't know, we can play with the geometry of our struts. Okay, so now since we are in Kangaroo, what we are going to try to implement is, of course, this kind of grab goal who allows the user to try to interact with the Kangaroo objects directly in Rhino. So in order to do that, we have to fix this definition just a bit, because first we want to explode this tree, and you are going to see why in just 1 second, hopefully. So these are my Kangaroo objects, and the thing is that now I want to add add this other component here. So this comes here, this comes here, and now I have created another, let's say, tree structure of Kangaroo goals, but now with my grab goal as well. So let me put this guy here. I hope this strength is okay. Let's test it later. And of course, now I'm getting an error here because I have to use this tree as, let's say, example or pattern. Okay, so now let's reset this thing, and we can try. And now we can try just playing with this, but if you can see any kind of change, that's probably because we have to fix the strength and set, I don't know, perhaps 10,000 instead of 1. So let's reset this guy, and now we can try distorting our Tensegrity. So first let's hide the geometry because we don't need that anymore, and let's set instead of 10,000, let's say like 100,000, and let's reset this definition. And now we can start playing with our Tensegrity structure, and yes, we can see how we can deform it. And for instance, this can be also very interesting to understand more how Tensegrity structures work, because let's say if we try to push this guy to this side, we can see that we are losing tension in the cables on this side. You can see that now they are green, they don't have tension anymore, and the cables on the other side are getting more, let's say, tension stresses. And now we can release that, and we can see how all cables get tension again. So now it's kind of funny. I mean, you can try deform it, and you can check that the Tensegrity is actually a stable structure, and just you can play with it however you want. And yes, I think that was basically it. I hope you had fun creating this plugin, and now you are able to create your own object-oriented plugins. So yeah, have fun with that.